In example 5, we finally get to the fun part where we start to solve systems of 3 equations, 3 unknowns using augmented matrices and row operations by hand. I'll tell you now that, especially if this is your first time working these sorts of problems, they can be a little complicated and it can be confusing at first. Fortunately, the sorts of problems of this type that I ask you to do by hand, they're going to be simpler examples of systems of 3 equations, 3 unknowns. You're also going to see that these problems can be a little bit lengthy, and as a result, this video is probably going to be a little bit on the longer side. If this is your first time seeing this material, I encourage you to watch at least parts A and B, and then see how comfortable you feel with the concepts. And if you think you're still a little sketchy, then go ahead and watch parts C and D. But if after watching the first couple of parts of this video you feel fairly confident with the ideas, then there's no need to go on and watch parts C and D. There's not really any new information or examples contained, or there's not really any new information contained there. It's just more examples of the same concepts. Okay, so in part A, I have this system that I want to solve using row operations. So my first step is to put this in an augmented matrix. So I'm actually going to do something a little bit different on this problem. I'm going to start by seeing if any of my rows are divisible by anything. By doing this, I'm going to save myself a step or two once I get into the work of doing the row operations. And so, looking at the very first row, it looks like everything in that row is actually divisible by 3. So I'm going to go ahead and reflect that. I'm going to go ahead and do that division as I put it into the augmented matrix. So I'm going to get 102, 87 divided by 3 is 29. And then I'm going to have 3, 4, 6, 107. The second row isn't divisible by anything, so I leave it alone. Just like the third row, it is also not divisible by anything. So I'm going to leave it alone as well. Okay, so now I need to get this into RREF form. So before I jump into that, let me just give you a recap, or let me just kind of give you a quick review of the process that we are going to use. Just like with systems of 2 equations, 2 unknowns, there's a particular form that we are going to be working toward, the RREF form. In an ideal situation, we're going to get a matrix that looks a little like this on the left-hand side, and then we're going to have some numbers, doesn't really matter what they are, on the right-hand side. If we can achieve this, then we are working under the ideal situation, and we're going to have a unique solution. So the process that we are going to use is we're going to work column by column. So we're going to start with the first column, and our first priority is to put a 1 where we need it in the first column. Then we're going to use that 1 to zero out these other entries. Then we move on to the second column. And again, our first priority is to get a 1 where we need it. Once we get that 1, we're going to use it to zero out these other entries. So the fourth step will be using the 1 in the second column to zero out the other entries. Then we move on to the third column. Once again, our first priority is to get a 1 where we want it. Once we have that 1, we're going to use it to make these other entries 0. If we can get to this point, then we can read the solution off. Okay, so let's see how this works in practice. Looking at our matrix, our very first priority is to put a 1 in the upper left-hand corner. But we already have that, so we don't need to do anything with that entry. So the next thing I need to do is zero out the other entries in the first column. I only have one non-zero entry in the first column, and that's a 3. Remember, I need to use the 1 in the first in the first column to turn that 3 into a 0. So what I need to do is I need to take the first row and multiply the entire first row by minus 3. If I do that, I end up with minus 3, 0, minus 6, and minus 87. Now that I have these numbers, I'm going to take them and add them up to the second row. I'm going to add them to the second row. and that results in the following matrix. The first row does not change, 1, 0, 2, 29. Even though I multiplied it by minus 3, that was just a temporary calculation. The second row, however, does change. I get 3 minus 3 is 0, 4 plus 0 is 4, 6 minus 6 is 0, 107 minus 87 is 20. And then the third row stays the same. I did not do anything with the third row. Okay, so now my first column is entirely how I want it. So I move over to the second column, and the first thing I need to do is turn this 4 into a 1. So I'm going to multiply the second row by 1 over 4. In other words, I'm going to divide by 4. If I do that, I get the following matrix. 1, 1, 0, 2, 29, 0, 1, 0, 5, 0, 3, 2, 35. Okay, so now looking at the second column, my next step is to turn this 3 into a 0. So I need to use the 1 in the second row. So I'm going to take the entire second row and multiply by minus 3. So I'm going to take the second row and multiply by minus 3. And that gives me 0, minus 3, 0, minus 15. And then I'm going to take these numbers and add them to the third row. Okay, so let's see what that gives us. Nothing happened to the first row, so it's exactly the same. The second row is still the same. It's only the third row that changes. And the third row becomes 0, 0, 2, 35 minus 15 is 20. Okay, so at this point, my first column and my second column are both how I want them. Going on to the third column, I need to turn this 2 into a 1. So I'm going to multiply the entire third row by 1/2 or divide by 2. So that's going to give me 1, 0, 2, 29, 0, 1, 0, 5, and the third row is 0, 0, 1, 10. Okay, so now the next step, and in fact the last step, the only entry we have left to change is this 2. So I need to take the very last row and multiply all of its entries by minus 2. If I do that, I'm going to get 0, 0, minus 2, minus 20. And then I add these entries to the first row, and that leaves me with the following matrix. The first row becomes 1, 0, 0, 29 minus 20 is just 9, 0, 1, 0, and 5, then 0, 0, 1, and 10. So now I'm done. My matrix is in RREF form, and so I can read off my solution, which is x equals 9, y equals 5, z equals 10. Okay, so if this concept is truly review for you, if you've seen this before, and you feel comfortable after this example, then you might want to stop the video here. But for most of you, I would definitely encourage you to go on and at least watch Part B. Now that you've seen one example, let's see if you can work through. You might want to try to work through the second one by yourself before actually watching the video. Okay, but either way, once again, I'm going to start by putting the matrix into putting the system into an augmented matrix. Just like before, I'm going to start by seeing if I can divide any of the rows by anything. It looks like I can divide the first row by 2, which will leave me with 1, 3, 6, and 13. And it looks like the second row even is divisible by 3. If I divide that by 3, I get 0, 1, 2, and 4. The third row, however, is not divisible by anything. It looks like it's almost divisible by 3, but that 20 keeps that from happening. Okay, so this is the augmented matrix I'm going to start with. Looking in the first column, I already have a 1 exactly where I want it. So my first step is to turn this 3 into a 0. To do that, I take the first row and multiply by minus 3. And that gives me minus 3, minus 9. Then I have 6 times minus 3, which is minus 18. 13 times minus 3, which is minus 39. So I carry out this calculation. The first row is 1, 3, 6, 13. The second row is still the same, 0, 1, 2, 4. The third row now, though, becomes 0, 0, 2, 45 minus 39 is 6. Okay, so let's see where we are. First column is fine. Looking at the second column, I have a 1 where I want it, so I need to zero out this 3. That would be the next step. So to use the 1, I need to use the 1 in the second row. And if I want to turn the 3 into a 0, what this means is I need to take the second row and multiply by minus 3. So that gives me 0, minus 3, minus 6, and minus 12. Then I take these entries and then add them to the first row. And this leaves me with 3 minus 3, which is 0. 6 minus 6, which is 0. 13 minus 12, which is 1. And then none of the other rows change. So the second row is still this, and the third row is still this. So now I move over to the third column, and I need to make this into a 1. So I need to divide this entire row by 2. So I multiply by 1/2, and this leaves me with the first row is exactly the same. Second row is exactly the same. It's only the third row that changes, and that changes to 0, 0, 1, 3. Looks like I only have one more step. I need to get rid of this 2. So I am going to take the third row and multiply by minus 2. That gives me 0, 0, minus 2, minus 6. And now I'm going to take these entries and add them to the second row so that I can get rid of that 2 in the second row. If I do that, I'm left with this matrix. 1, 0, 0, 1, 0, 1, 0, minus 2, 0, 0, 1, 3. So my final answer is x equals 1, y equals minus 2, z equals 3. Okay, so at this point, I definitely encourage you to try the next couple of examples before you watch the video. So you may want to pause the video right here and then come back to it later. Obviously, I'm going to go ahead and move on to solve them. But once you're done trying them on your own, then definitely come back and watch these videos. Okay, so example C. I start by looking at the first row. It looks like everything there is divisible by 3. So I can start out with this version of the first row. Well, the second row actually is also divisible by 3. So I can jump straight into this. The fourth row is divisible by 4. Everything in the fourth row is divisible by 4. So I can turn this into 1, 4, 5, and 10. And kind of glancing at this, it looks like this system is going to be pretty easy to solve. I think it's only going to take us a few steps. We have the 1 in the upper left-hand corner, so our next step is to turn this into a 0. So I need to multiply the first row by minus 1. In essence here, what I'm doing is taking the third row and subtracting off the first row. I'm going to get negative 1, negative 4, negative 4, and negative 5 when I multiply the first row by minus 1. And again, I'm going to add these entries to the third row. That will give me this new matrix, 1, 4, 4, 5. The first row doesn't change. 0, 1, 1, 1. And then I'm going to get 0, 0, 1, and 5. Okay, so now I go into the second column. Once again, I already have the 1 where I want it, so I just need to zero out this 4. So I'm going to take the second row, because that's the one that contains my 1 here in the middle column. So I take my second row, and I multiply by negative 4. 0 times negative 4 is 0. 1 times minus 4 is minus 4. 1 times minus 4 is minus 4, and so on. So I add these entries, add these numbers to the first row, and that gives me 1, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 5. Okay, well, I only have one more entry to change. That is this one. I apologize. For some reason, my tablet, the monitor blacks out on occasion. Okay, here we go. I just got it back. So I need to change this 1 into a 0. So I'm going to take the last row, multiply by minus 1, and that's going to give me 0, 0, minus 1, minus 5. And then I add those results to the middle row. And that leaves me with my final matrix, which will be 1, 0, 0, 1, 0, 1, 0, minus 4, 0, 0, 1, 5. And so my final answer is x equals 1, y equals minus 4, and z equals 5. Okay, so one more example of this sort. Part D. I need to start by putting it into an augmented matrix. And again, I'm going to do my standard simplifications in this first step. I can divide the first row by 4. So that gives me 1, 0, 2. I apologize, my screen blinked again. Okay, so 1, 0, 2, I'm dividing everything by 4. So then I get 32 divided by 4, which is 8. Nothing, I can't divide the second or third rows by anything. So I get 1, 3, 2, 32, and 0, 1, 3, 26. Step 1 would be to turn this into a 0, since I already have the 1 above it. So I'm going to take the first row and multiply it by minus 1. So that gives me negative 1, 0, negative 2, negative 8. And I'm going to take these entries and add them down to the second row. By doing this, this is going to allow me to get rid of that 1 that I want to turn into a 0. First row stays the same. Middle row becomes 1 minus 1, which is 0. 3 plus 0, which is 3. 2 minus 2, which is 0, and 32 minus 8, which is 24. And then the third row stays the same. So, next step, I need to turn this into a 1. So I multiply by 1/3. Again, that's the same thing as dividing by 3. I divide the entire second row by 3. So the first row doesn't change at all. The second row becomes 0, 1, 0, 8. And the third row becomes 0, 1, 3, 26. Now I need to use that 1 I just created in the second column to turn this into a 0. So I'm going to take the middle row and multiply by minus 1. That gives me 0, minus 1, 0, minus 8. And I add this to the third row. And that's going to give me this matrix. That 1 became a 0. So I get 0, 0, 3, 26 minus 8 is 18. Okay, almost done. Just a couple more steps. I need to turn this into a 1. So I multiply by 1/3. And that gives me, nothing changes but the third row. So these first two rows are exactly as they were. But the last row becomes 0, 0, 1, and then 6. So the very last step, I need to get rid of this 2. So I'm going to take the third row and multiply by minus 2. This gives me 0, 0, minus 2, minus 12. And then I'm adding those results to the first row so that I can get rid of that 2. And that gives me the matrix 1, 0, 0, minus 4, 0, 1, 0, 8, 0, 0, 1, 6. And my final solution then is x equals minus 4, y equals 8, and z equals 6. Okay, well there you go. I hope that helped. I hope that was all clear. If not, then let me know, and you can certainly come by my office hours and we can work through a few examples in person.